Parallelogram Law of Vectors. The parallelogram law of vectors can be applied to any situation where multiple forces are acting on an object. The weight displacement by a crane and launching of a stunt person from a cannon in a circus is an example of this law. Parallelogram law of vectors state that if two vectors acting simultaneously on a particle are represented in magnitude and direction by the two adjacent sides of a parallelogram, the resultant can be represented in magnitude and direction by the diagonal of that parallelogram. Principle: let two vectors P and Q act simultaneously on a particle O at an angle theta. They are represented in magnitude and direction by the adjacent sides OA and OB of a parallelogram OACB. Then the diagonal OC passing through O will represent the resultant R in magnitude and direction. Vector R is equal to vector P plus vector Q. R is equal to square root of P square plus Q square plus 2PQ cos theta. Materials required: grave sans apparatus, 2 hangers with slotted weights, a stone, strong thread, white drawing paper sheet, drawing pins, mirror strip, pencil, half-meter scale, compass, protractor. Procedure: fix a white drawing paper sheet to the board using drawing pins. Set up the grave sans apparatus by tying 3 pieces of thread in which the center one carries the unknown body and the other 2 pass through pulleys and carry equal weights. Trace the position of the images of the thread on the paper with the help of a mirror strip. Assuming a scale of 50 grams is equal to 2 centimeters, mark OA is equal to 4 centimeters and OB is equal to 4 centimeters to represent P is equal to 100 grams and Q is equal to 100 grams. Complete the parallelogram OACB and join OC. This represents the resultant vector R, which corresponds to the weight of the unknown body. OC multiplied by the scale will give you the value of the unknown weight S. Also calculate the weight of the body R using the equation R is equal to square root of P square plus Q square plus 2PQ cos theta. After measuring the angle AOB theta using a protractor, mean of the two values of S and R will give the correct mass of the body W equal to S plus R the whole divided by 2. Repeat the experiment with different suitable values of P and Q. Applications: the parallelogram law of forces is a basic law in vector addition. It is applied in mechanics in such ways as lifting of load by cranes, bracket, stay wires, etc.